So this will be the first journal of this 6 weeks. Second 6 weeks. So some of y'all didn't do so great on the journal test.
I blame it on me. How'd you figure out it was after?
Because there was 2 people, and the other one was a guy,
Oh,
and one had nice handwriting, and the other one didn't. So I gave Abby the nice handwriting.
Wait, who was the guy? See, if that was me in that situation, I would probably be bad. Yeah.
I know, but I just in my mind I felt like Abby had good handwriting. That was in my mind. I thought that.
Okay. Is it upside down?
So this 6 weeks I dropped the test grade. So some of y'all that would not have passed. Some of y'all just went up to a really high grade. Of course, the people that have probably helped the least were the people that already had a really, really high grade. If you've got 100 and I drop 100, or I drop it, and it doesn't really change that much. But anyway, it was helpful to quite a few people. It will not happen again. I don't drop test grades usually. So next 6 weeks, y'all will have a chance to do a little project that will add 5 points to your final average. So like if you look and you see right now your final average is a 75, that would go up to an 80. So not 5 points to a test, not 5 points to your average. So I'll tell you all about probably that next week, and then you can kind of think about if you want to do it. Somebody said it's like for insurance, which is a good way to think about it. It should say good way to think about it.
I think I should have how you could use your
Lowry loop can be used to drop a daily grade. You can only use 2 of those in 6 weeks, or you can add 5 points to every test that you take. But you have to turn it in with the test. All of your quizzes get averaged together, and that's a test grade. So it may drop it as a daily grade, but it doesn't drop it averaging that together. For, I would say 98%, we only had 4 quizzes, but they were pretty easy quizzes, like safety quiz. I mean, they were really some easy quizzes. Maybe the SIG was the hardest. I would say for 90% of the people or more, 99% of the people, that little quiz average helped them because it was a test grade they could keep, and then they could drop another lower test grade. All right. Let me hand y'all back here. All right, so on our journal, anybody remember the 3 subatomic particles?
No.
Protons, neutrons, and electrons.
Protons, neutrons, and electrons. Does anybody remember their charges? Protons are positive, neutrons are neutral, and electrons are negative. So we're going to start studying the atom. And we're going to start with a little background and a little history today. We're going to do a very little bit of notes, and then y'all are going to do the rest by yourself today. Notes, you've got a new set of notes up there. All right. Yes, ma'am.
Abby, reading mine too.
All right, so we're going to start off with 3 basic laws that kind of govern chemical reactions. And we've already talked about 2 of these laws already. The first one is the law of conservation of mass. And it says that Mass is neither created nor destroyed during a ordinary chemical reaction or a physical change. So we're talking about atoms now. We're working to chemical reactions, and we'll work to stoichiometry and then gas laws. Stoichiometry. So that means, if you remember, you start with your reactants. Oh, did anybody appreciate my?
Yes.
Thank you.
I noticed that when we were talking
I
about
said
it.
it
It was
whenever
so
I
cute.
saw it.
I was gonna tell you it's cute. when we were-
Miss Baker got it for me, and I saved it just until we talked about subatomic particles today. She got one for Miss Corman, and it had DNA, and then it had RNA, and then the DNA was asking the RNA, "You're still single?"
That's funny.
All right, so remember, reactants go to products. So that means that my mass of my reactants would be equal to the mass of my products. The number of atoms of each element also has to be equal. That's why we balance equations. And I know you have balanced equations before. If we think about water breaking down into hydrogen and oxygen, if I look at that, I couldn't leave it like that because I have 2 hydrogen, but look over here, I only have 1 oxygen, and here I have 2. So remember, you balance your equations with coefficients. Y'all did that in 8th grade, I believe. And we'll get back to doing that. My mass of my reactants is equal to the mass of my products. Always is true. Now, sometimes we might measure the mass of our reactants and we might measure the mass of our products, and it seems like our products have a less mass. Because anybody think why that might happen? Exactly. If one of your products is the gas and it escapes, then it's going to seem like you've lost some mass, but in reality, you just didn't have a way to gain or to mass out that gas. I'm using the word gas quite a few times there. Okay, law of definite proportions states that a chemical compound contains the same elements in exactly the same proportions by mass, regardless of the size or the sample. So kind of like a recipe. If I have table salt, which is sodium chloride, I can have 5 pounds or I can have a teaspoon. By mass, it's still going to be 39.34% sodium and 60.66% chlorine. And then the last one, which we have talked about, is the law of multiple proportions. It says if 2 or more compounds are composed of the same 2 elements, then the ratio of the masses of the second element combined with a certain mass of the first element is always a ratio of small whole numbers. Remember, those small whole numbers are called subscripts. So that's a whole lot of words, but what it's saying is if I can take the same elements and if I combine them a little bit differently, they're going to give me completely different compounds. So if I'm looking at carbon and oxygen, if I have 1 carbon and 2 oxygen, I get carbon dioxide, which is needed for what? For who's breathing? Plants breathing. I don't know if we really should say plants breathe, but they need it. If I could have just 1 carbon and 1 oxygen, then I have carbon monoxide.
Wait, I thought they needed carbon monoxide. We needed
Nobody, I don't know of anything that needs carbon monoxide. We don't want carbon monoxide. That's
Oh,
deadly.
I thought they took in carbon monoxide and
No.
left out
Oxygen. They take in carbon dioxide and they leave out oxygen. And then we breathe oxygen and we expel CO2. I won't tell them it's carbon.
Yeah, please don't.
Just be our little secret. And Sonic Cokes is how you bribe me. Sonic Cokes, Diet Coke is wine. That's how you bribe me. Yeah. Yes, for sure. All right, so starting a little bit, talking about a little bit of the history. First guy that we're going to talk about is John Dalton, and this was in the early 1800s, and he came up with Dalton's atomic theory. He was an English school teacher because school teachers are very, very smart. In case y'all didn't know that. Just throw that out. Yes, we are. And it has 5 postulates or 5 parts.
Wasn't this, Norman an English teacher?
Yes, you did start off as an English teacher. Isn't that crazy?
Good.
Well, I mean, yeah, that part still makes sense, but how much she knows about biology is funny that she started off as English. So all matter is composed of extremely small particles called atoms. Atoms of the same element are exactly the same in size, mass, and other properties, and then atoms of different elements would be different. And remember, this is back in 1800, so there wasn't a lot of, like, balances probably weren't that great. Things that you could really use to measure stuff and look at stuff weren't that great back then. Atoms cannot be subdivided, created, or destroyed. And atoms of different elements combine in simple whole number ratios to form chemical compounds. And in chemical reactions, atoms are combined, separated, or rearranged. So all of that is still found to be true except for number 2 and number 3. We now know that atoms can be subdivided into protons, neutrons, and electrons. No, it's not easy. It has to be done through a nuclear reaction, but it could be. And then also atoms of the same element are not always exactly the same. We have something called isotopes. So isotopes are atoms of the same element that have different number of neutrons. So that gives them a different mass number. Is that correct? Oh, so on English,
I missed 7 on English, missed 1 on math, and omitted 1 on math. Basically what it was like, there were 3 questions that I could have scored points on, and that question I had no hope of scoring anything.
he's talking about his SAT test, which he did very well on.
Are they, good job. Here's my man.
All right. So postulates 2 and 3 have changed, and you don't really need to write all that in the red because I kind of just shorthanded it when I wrote it off to the side. All right, little bit about the early models, and then you'll do the rest of the history on your own. So the first guy that kind of started about coming up with the word atom and started talking about matter being composed of atoms was Democritus back in 400 BC. That's a long time ago. But then his teacher, Aristotle, who was known a lot more, came along and he said Democritus was wrong and people believed Aristotle. Although 2,000 years later, they found out Democritus was right and Aristotle was wrong. And he probably did try to. So the first subatomic particle to be discovered was the electron. And it was discovered by J.J. Thomas with the cathode ray tube experiment. And the reason the electron was the first to discover is because it's negative and it's small. Obviously, protons, neutrons, electrons are all small, but the electron is much smaller than the other 2. And then with this negative, then it could be manipulated by magnetic fields. So it was able to be discovered first. After that, they knew that an atom was neutral. It did not have an electrical charge. So if they had discovered something negative, they had to discover something positive. So that's why the proton was the next to be discovered. And then finally, the neutron would have been the last one to be discovered. It was hardest because it didn't have a charge. And the only reason they knew that there was still one more particle is because they still had some mass that they had to make up for. So Rutherford came along and he put that information together and he came up with the nucleus by working with something called the gold foil experiment, where he would put positive alpha, or where he would put alpha particles through a little thin sheet of gold, and then they would either go straight through or they may be go off in different directions if they hit another nucleus. Remember, within the nucleus, that's where your protons and your neutrons are. So nucleus holds the mass of the atom. Your electrons are in the electron cloud. So that's where you're going to get the volume of your nucleus. That's where it's going to spread out. So I went through a list of scientists and they would come up with different models and different drawings of them. And that's what we're going to look at now. So we're going to stop there on our notes. So I'm going to give you two things. I'm going to give you one that has a front and back. And that's a list of scientists and a little blurb about each scientist. And then it also shows what their model looked like. Okay? So that is yours, and you'll use it to complete the other worksheet. Y'all's worksheet doesn't look just like this. The other worksheet. This you'll want to keep with your notes. The worksheet is what you'll want to turn in. Oh, let me get out of here. All right. Jasmine, if you go into your Google Classroom. Under classwork. It's also posted in there. Or I'm sorry, daily work then. History of the atomic model. That's like the notes part. And you'll use that to complete your scientist worksheet, which you'll need to type on with Cami.